Hello everyone, welcome to my third video lecture on numerical integration. In the previous videos, we discussed four important formulae of numerical integration and worked out couple of examples. In this video, we shall work out few more examples. Let us consider the following example. Evaluate integral from 0 to 6 1 divided by 1 plus x square with respect to x using trapezoidal rule, Simpsons 1/3 rule, Simpsons 3/8 rule and Wedel's rule. So in this problem we have to apply all the four quadrature formulae to evaluate the value of this definite integral. This is an important question and this has been asked in the BSc final year examination of Gulbarga University Kalburgi in the year 2017 and also in the year 2019 for 6 marks. So let us solve this example. From the given example, we come to know that x0 is the lower limit, that is 0 given in the problem, and xn is the upper limit, that is 6, and f of x is 1 divided by 1 plus x square. So let us write down the things. Here x0 is 0, xn is 6 and y is 1 divided by 1 plus x square. Now we have to compute what is n and what is h. So we know that in order to compute h, we know that xn is equal to x0 plus nh. So this implies x0 is 6, x0 is 0 and n is unknown. In this case, h is also unknown. So this implies h is equal to 6 divided by n. In this question, it is asked to evaluate the given definite integral with the help of all the four rules. And there was a condition we have seen in the first video on Simpsons 1/3 rule. To apply Simpsons 1/3 rule, n must be an even number, that is, it must be a multiple of 2. To apply the Simpsons 3/8 rule, it must be a multiple of 3. To apply the Wedel's rule, n must be a multiple of 6. Therefore, it is convenient if we choose n is equal to 6. If we choose n is equal to 6, definitely 6 is a multiple of 2, that is even number, Simpsons 1/3 rule can be applied. 6 is a multiple of 3, Simpsons 3/8 rule can be applied. 6 is a multiple of 6, therefore Wedel's rule can be applied. So therefore it is convenient to choose n equal to 6. Therefore from this expression, h value is 6 divided by 6, it is going to be 1. Now we got the value of x0, n and also h. Now let us compute the value of y at different values of x0. Now x1 is equal to x0 plus h. So x0 is 0, 0 plus 1 is 1. Before going to x0, it is our duty to find out what is the value of y at x0. Since x0 is 0, it implies y0 is equal to, you look at the definition of y, it is 1 divided by 1 plus x square. So it is going to be 1 divided by 1 plus x0 square. x0 is 0, therefore y0 is 1 divided by 1 plus 0, it is 1 divided by 1, 1. So we got x1 as 1. This implies y1 is equal to 1 divided by 1 plus x1 square. This implies y1 equals to 1 divided by 1 plus 1 square, that is 1 divided by 1 plus 1 2, it is 0.5. So we got the value of y1 as 0.5. Similarly, let us evaluate x2. x2 is equal to x1 plus h. Of course it is 1 plus 1, 2. That implies y2 is going to be 1 divided by 1 plus x2 square. It is 0.2 after simplification. x3 is x2 plus h. Definitely it will be 2 plus 1, 3. So that implies y3 equal to 1 divided by 1 plus x3 square. That is 1 divided by 1 plus 3 square. That is going to be 0.1. x4, that is equal to 1 plus 3, 4. That implies the value of y at x4 is y4 and it is 0.0589. x5 is x4 plus h, that is 4 plus 1, 5. That implies y5 equals to 1 divided by 1 plus x5 whole square according to this definition. So x5 is 5, 5 square is 25, 25 plus 1, 26 in the denominator, 1 by 26 is 0.0385 after simplification. x6, of course x6 must be the upper limit, it is the final value. x5 is 5, x5 plus h, 5 plus 1, it is 6. You look at that, n is 6, x6 is 6, and this is same as the upper limit of the integral, that is 6. So now let us evaluate the value of y at x6 and take it as y6, and y6 is of course 1 divided by 1 plus x6 square, that is 1 divided by 1 plus 6 square, it is 0.027 after simplification. So we got all the values x, y0, y1, y2, y3, y4, y5, y6. Also we know the value of h. Let us use the formula one after another. So the first formula is trapezoidal rule. So what is the trapezoidal rule? It is very easy to write. The given integral I equals to h by 2 into the bracket the first value and the last value of y plus 2 times all the remaining values, y1 plus y2 plus y3 plus y4 plus y5. That is, this is the last value, the last of the intermediate values. So now our duty is to substitute the values of h, y0, y1 and so on. The value of h is 1 by 2 into the bracket. The first value is y0, which is 1, plus y6 is, just now we got 0.027 plus 2 times the intermediate values, that is 0.5 plus 0.2 plus 0.1 plus 0.0589 plus 0.027. 385, that is. So we have substituted all the values, and if we simplify the bracket and divide by 2, the answer is going to be 1.4108. So this is the first answer, that is the value of the given definite integral computed as per the trapezoidal rule. Now the question is to find the value of the same definite integral using Simpsons 1/3 rule. In the second step, we shall use Simpsons 1/3 rule. So what is the Simpsons 1/3 rule? It is integral I equals to 1/3 means h by 3 into the first value plus the last value plus 4 times of all the odd subscripted values of y, that is y1 plus y3 plus y5 plus 2 times the even subscripted values y2 and y4, that is y2 plus y4. So again our duty here is to write down the values. H value is 1 by 3 as it is, plus the first value is 1, y6 is 0.027 plus 4 times y1 is 0.5, y3 is 0.1, y5 is 0.0385 plus 2 times y2 is 0.2, y4 is 0.0589. So if we simplify this, the answer is going to be I equal to 1.3662. So this is the value of the same definite integral computed according to the Simpsons 1/3 rule. Now we have to evaluate the given definite integral using the Simpsons 3/8 rule, that is the continuation, and we shall write down the formula. Integral I equals to 3/8 means 3h by 8 into the bracket the first value y0 plus the last value y6 plus 2 times of the subscripts with that is y value with the subscript multiple of 3, that is y3. y6 is already here, therefore only one term coming over here, plus 3 times of the remaining values. y0 has been taken, so it is y1 y2, y1 plus y2, y3 has come over here, therefore let us jump to y4, and lastly it is y5. Again it is our duty to substitute all the values. H value is 1, y0, y1 and all other values should be substituted from the above list, and that gives us, after simplification, the value of integral to be 1.3571. I have written directly the substitution of these values and simplification is left. And now the last method, that is Wedel's rule, we shall apply to evaluate the given definite integral, and the formula is 3h by 10, and I have told you a very simple way of writing the bracket, that is the coefficients. First we should write down all the symbols. y0 plus y1 plus y2 plus y3 plus y4 plus y5 plus y6. Now the coefficients are like 1, 5, 1, 6, 1, 5, 1, 5, 1. So it is y0 plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus y6. So again our duty is to substitute h, y0, y1, y2 and so on. After substituting the respective values and after simplification, the answer is going to be 1.3735. So we have applied the different methods, that is all the four rules, that is the quadrature rules, Simpsons 1/3 rule, Simpsons 3/8 rule, Weddell's rule and also the trapezoidal rule, and we got the value of the given definite integral like 1.357 in the Simpsons 3/8 rule and 1.3735 in the Weddell's rule. So this is how one can apply the quadrature formulae, that is the formulae of numerical integration to evaluate the given definite integral. So this completes the first problem. I request you please watch the next video for the next examples. Thank you.